Download this code from codegive.com, link in the description below. Comprehensive tutorial on app management, traffic isolation, IP binding, pppoe users, hotspot, and static IP with code examples, Linux/network focused. This tutorial covers a broad range of network management and security concepts commonly used in scenarios like public Wi-Fi hotspots, small business networks, or managed service provider environments. We'll explore how to isolate user traffic, manage applications, assign IP addresses using different methods, static, dhcp, pppoe, create hotspots, and bind IP addresses to specific MAC addresses for enhanced security. Important note: this tutorial assumes a Linux environment and uses common networking tools. The specific commands and configurations might vary depending on your distribution and network setup. Always back up your configuration before making changes. Table of Contents *. 1. Introduction, the need for control and isolation. 2. Application management, app isolation/QoS. * 2.1 Understanding traffic shaping and TC. * 2.2 Identifying application traffic, iptables, contract. * 2.3 Creating TC classes and filters. * 2.4 Code example, Bash script for traffic shaping. 3. Traffic isolation, VLANs, namespaces. 3.1 VLANs, virtual LANs concept and configuration. 3.2 Network namespaces, creating isolated networks. 3.3 Bridging and routing between namespaces. 3.4 Code example, network namespace setup. 4. IP binding, static dhcp leases. 4.1 Understanding dhcp and MAC addresses. 4.2 Static dhcp leases, dhcpd.conf. 4.3 Code example, dhcpd.conf configuration. 5. pppoe user management. 5.1 What is pppoe? Point-to-point protocol over Ethernet. 5.2 Installing and configuring pppoe server, pppoed. 5.3 User authentication, CHAP secrets. 5.4 Assigning IP addresses, IP pools. 5.5 Code example, pppoed configuration. 6. Hotspot creation, hotspot, DNS mask. 6.1 Setting up a wireless access point with hotspot. 6.2 DHCP and DNS server with DNS mask. 6.3 Captive portal, optional. 6.4 Code example, hotspot and DNS mask configuration. 7. Static IP configuration. 7.1 Manually assigning IP addresses. 7.2 Configuring network interfaces. 7.3 Routing and default gateway. 7.4 Code example, network interface configuration. 8. Security considerations, firewall, IDS/IPS. 9. Putting it all together, a practical scenario. 10. Troubleshooting. 11. Conclusion. 1. Introduction, the need for control and isolation. In many network environments, it's crucial to control and isolate traffic for security, performance, and management reasons. For example, public Wi-Fi hotspots prevent users from accessing each other's devices, prioritize bandwidth for essential services, and prevent abuse. Business networks separate guest networks from internal networks, restrict access to sensitive resources, and manage bandwidth usage by different departments. Managed service providers, MSPs provide isolated virtual networks for each client, manage application performance, and ensure security. The techniques described in this tutorial enable you to achieve these goals. 2. Application management, app isolation/QoS. Application management involves controlling and prioritizing network traffic based on the application generating it. Quality of service, QoS, techniques are used to ensure critical applications get the bandwidth they need while less important applications are throttled. 2.1 Understanding traffic shaping and TC. TC, traffic control, is a powerful Linux command line utility for shaping network traffic. It works by creating a hierarchy of queues, classes, and filters that determine how packets are handled. Queues, disks determine the queuing discipline. Common options include FIFO_fast, a simple FIFO, first in, first out, queue with priority levels. HTB, hierarchical token bucket, a class-based queue that allows you to allocate bandwidth to different classes. This is the most common choice for QoS. FQ_codel, fair queuing with controlled delay. Good for reducing buffer bloat and improving interactive traffic. Classes represent different traffic types. You can assign bandwidth limits, priorities, and queuing disciplines to each class. Filters determine which packets belong to which class. Filters can be based on IP addresses, ports, protocols, and other criteria. 2.2 Identifying application traffic, IPTables, contract. To shape traffic effectively, you need to identify the application generating it. IPTables and contract are used for this. IPTables the Linux firewall. It can be used to mark packets based on their source and destination IP addresses, ports, and protocols. Contract a connection tracking module that keeps track of active network connections. You can use contract to identify applications based on their behavior. This is more complex but can be more accurate. For example, you could identify HTTP traffic, port 80, and SSH traffic, port 22, using IPTables. Identifying specific applications like YouTube or Netflix requires more sophisticated techniques, such as deep packet inspection, DPI, which is beyond the scope of this basic tutorial. 2.3 Creating TC classes and filters. Here's the general process for creating TC classes and filters. 1. Identify the network interface. Find the interface you want to shape traffic on, example eth0, 0. 2. Create a root disk *, usually, an HTTP queue. 3. Create classes *, define classes for different traffic types. Assign bandwidth limits and priorities to each class. 4. Create filters *, use IPTables to mark packets and then use TC filters to assign packets to the appropriate class based on the IPTables mark. 2.4 Code example, Bash script for traffic shaping. This example prioritizes SSH traffic and limits bandwidth for other traffic on the eth0 interface. It uses IPTables to mark SSH traffic and TC to create the traffic shaping rules. Explanation ****. Interface, the network interface. ***disk, the root queuing discipline ID. **SSH_class, other_class, class IDs for SSH and other traffic, respectively. **bandwidth, SSH_rate, other_rate, bandwidth limits. Adjust these based on your network capacity. *TC disk del, removes any existing TC rules. Asterisk tseek disk add, creates the root HTB disk. Asterisk tc class add, creates the SSH and other traffic classes. Asterisk iptables tmangle, adds iptables rules to mark SSH traffic, packets with destination port 22 or source port 22. The tmangle table is used for packet modification. Asterisk tc filter add, creates a tc filter to assign packets marked with 1 to the SSH class. To run this script asterisk 1 save it as traffic_shape.sh. To make it executable, mod plus x traffic_shape.sh. 3 run it with root privileges, sudo /traffic_shape.sh. To verify the configuration asterisk. Important considerations asterisk. Asterisk this is a basic example. More complex QoS configurations can be created to prioritize different applications and traffic types. Asterisk you may need to adjust the bandwidth limits and priorities based on your network needs. Asterisk identifying application traffic accurately can be challenging and may require more advanced techniques. 3. Traffic isolation, VLANs, namespaces. Traffic isolation prevents different groups of users or applications from accessing each other's network traffic. This enhances security and privacy. Asterisk 3.1 VLANs, Virtual LANs concept and configuration. VLANs are a technology that allows you to logically divide a physical network into multiple virtual networks. Devices on different VLANs cannot communicate directly without routing. VLANs are typically configured on network switches. Asterisk VLAN IDs asterisk each VLAN is assigned a unique ID, 1 to 4094. Asterisk tagged and untagged traffic asterisk traffic on a VLAN can be tagged with the VLAN ID, 802.1q header. Untagged traffic is considered to be on the native VLAN of the port. Asterisk switch configuration asterisk you need to configure your switches to assign ports to specific VLANs. This typically involves configuring trunk ports, which carry traffic for multiple VLANs, and access ports, which carry traffic for a single VLAN. Example, Cisco switch. Important asterisk VLAN configuration is highly dependent on the type of switch you are using. Refer to your switch's documentation for specific instructions. Asterisk 3.2 Network namespaces, creating isolated networks. Network namespaces provide a more complete form of isolation than VLANs. They create completely separate network stacks, including interfaces, routing tables, and firewall rules. Each namespace behaves like a separate virtual machine. Asterisk creating a namespace asterisk the ipnetunc command is used to create and manage network namespaces. Asterisk assigning interfaces asterisk you can move existing network interfaces into a namespace or create virtual interfaces, VETH pairs, to connect namespaces to each other or to the outside world. Asterisk 3.3 Bridging and routing between namespaces. To allow communication between namespaces or between a namespace and the host network, you need to create virtual interfaces, VETH pairs, and configure routing. Asterisk VETH pairs are virtual Ethernet cables that connect two namespaces. Traffic sent on one end of the VETH pair is received on the other end. Asterisk bridges asterisk a bridge interface allows you to connect multiple network interfaces, including VETH interfaces, into a single logical network. You can then assign an IP address to the bridge interface. Asterisk routing asterisk you need to configure routing rules to allow traffic to flow between the namespaces and the host network. Asterisk 3.4 Code example, network namespace setup. This example creates two network namespaces, NS1 and NS2, connects them using a VETH pair, and configures IP addresses. Explanation asterisk. Asterisk IP netUnc add, creates the namespaces. Asterisk IP link add, creates the veth pair. The netUnc option specifies the namespace to which each end of the veth pair belongs. Asterisk IP netUnc exec, executes a command within a specific namespace. Asterisk IP address add, assigns an IP address to the interface. Asterisk IP link set, brings the interface up, enables it. Asterisk IP route add, adds a default route, optional. Asterisk ping, tests connectivity. To run this script asterisk 1. Save it as netunc_setup.sh. 2. Make it executable, mod plus x netunc_setup.sh. 3. Run it with root privileges, sudo /netunc_setup.sh. To verify the configuration asterisk. Connecting namespaces to the host network, using a bridge. To allow the namespaces to access the internet, you can create a bridge interface on the host network and connect the namespaces to the bridge. Here's an example. Explanation asterisk. Asterisk brctl adbor, creates a bridge interface. Asterisk IP address add, assigns an IP address to the bridge interface. Asterisk brctl addif, adds network interfaces to the bridge. Asterisk IP route add, adds routing rules to allow traffic to flow between the namespaces and the host network. Asterisk echo 1/proc/sys/net/ipv4/IP_forward, enables IP forwarding, so the host will route packets between the namespaces and the outside world. Asterisk iptables tnat a post routing $host_face j masquerade, configures NAT on the host, so traffic from the namespaces will appear to come from the host's IP address. This is needed for internet access. Important considerations asterisk. Asterisk network namespaces provide a strong form of isolation, but they can be complex to manage. Asterisk routing and firewall rules must be carefully configured to ensure proper connectivity and security. 4. IP binding, static dhcp leases. IP binding, also known as static dhcp leases, allows you to assign specific IP addresses to devices based on their MAC addresses. This provides a degree of control over the network and simplifies network management. Asterisk 4.1 Understanding DHCP and MAC addresses. Asterisk DHCP, Dynamic Host Configuration Protocol, a protocol that automatically assigns IP addresses, subnet masks, default gateways, and DNS server addresses to devices on a network. Asterisk MAC address, Media Access Control Address, a unique hardware address assigned to each network interface card, NIC. When a device connects to a network and requests an IP address, the DHCP server typically assigns an IP address from a pool of available addresses. With static DHCP leases, you can tell the DHCP server to always assign the same IP address to a specific device based on its MAC address. Asterisk 4.2 Static DHCP leases, dhcpd.conf. The configuration file for the DHCP server, usually dhcpd.conf or similar, depending on the DHCP server implementation, is used to define static DHCP leases. The general format of a static DHCP lease entry is asterisk host name, a host name for the device, optional. Asterisk hardware Ethernet MAC underscore address, the MAC address of the device. Asterisk fixed address IP underscore address, the IP address to assign to the device. Asterisk 4.3 Code example, dhcpd.conf configuration. This example shows how to configure a static DHCP lease in dhcpd.conf for a device with MAC address 00:11:2233:44:55 and assign it the IP address 192.168.1.100. Explanation Asterisk subnet defines the IP address range for the network. Asterisk range specifies the pool of IP addresses that the DHCP server can assign dynamically. Asterisk option routers specifies the default gateway IP address. Asterisk option domain name servers specifies the DNS server IP addresses. Asterisk host defines a static DHCP lease. To configure static DHCP leases asterisk 1. Edit the dhcpd.conf file, usually located at /etc/dhcp/dhcpd.conf or /etc/dhcp3/dhcpd.conf. 2. Add the host entry for each device you want to assign a static IP address to. 3. Restart the DHCP server. Example sudo systemctl restart ISC DHCP server or sudo service DHCPD restart. Important considerations asterisk ensure that the IP addresses assigned to static DHCP leases are outside the range of IP addresses assigned dynamically. Static DHCP leases can simplify network management and make it easier to identify devices on the network. Always back up your dhcpd.conf file before making changes. 5. pppoe user management. pppoe, point-to-point protocol over Ethernet, is a network protocol commonly used by ISPs to provide internet access to customers. It allows the ISP to authenticate users and assign IP addresses dynamically. 5.1 What is pppoe, point-to-point protocol over Ethernet? pppoe encapsulates PPP, point-to-point protocol, frames within Ethernet frames. This allows PPP's authentication, encryption, and compression features to be used over Ethernet networks. The pppoe process involves 1. Discovery *. The client broadcasts a pppoe discovery active discovery initiation, PADI, packet to find pppoe servers. 2. Offer *. The server responds with a pppoe active discovery offer, PADO, packet. 3. Request *. The client sends a pppoe active discovery request, PADR, packet to select a server. 4. Session *. The server establishes a pppoe session and assigns a session ID. 5. Authentication *. The client authenticates with the server using a username and password. CHAP, Challenge Handshake Authentication Protocol, is commonly used. 6. IP address assignment *. The server assigns an IP address to the client. 5.2 Installing and configuring pppoe server, pppoed. pppoed is a common pppoe server implementation. The installation process depends on your Linux distribution. For example, on Debian/Ubuntu. 5.3 User Authentication, CHAP Secrets. The CHAP Secrets file, /etc/ppp/chap secrets, stores the usernames and passwords for pppoe users. Each line in the file has the following format. *username, the username for the pppoe user. *server, the server name, usually *. *password, the password for the user. *IP_address, the IP address to assign to the user, or * for dynamic assignment. 5.4 Assigning IP addresses, IP pools. pppoe servers can assign IP addresses from a pool of available addresses. You typically configure the IP address pool in the options file, /etc/ppp/options or /etc/ppp/pppoe server options. You can also configure DNS servers, MTU, maximum transmission unit, and other pppoe options in this file. Asterisk 5.5 code example, pppoe deconfiguration. This example shows how to configure pppoe with a user, an IP address pool, and CHAP authentication. Assume the pppoe server's network interface is eth1. 1/etc/ppp/chap secrets asterisk. 2/etc/ppp/options, or /etc/ppp/pppoe server options. The file /etc/ppp/pppoe server options need these line 3 starting the pppoe server asterisk. The exact command to start the pppoe server depends on your Linux distribution. A common command is explanation asterisk. Asterisk ith1 specifies the network interface. Asterisk L192.168.2.1 specifies the local IP address of the pppoe server. Asterisk R192.168.2.2-254 specifies the range of IP addresses to assign to clients. Asterisk C enables CHAP authentication. To configure pppoe server asterisk. 1. Install the pppoe package. 2. Edit the /etc/ppp/chap secrets file to add user accounts. 3. Edit the /etc/ppp/options, or /etc/ppp/pppoe server options, file to configure the IP address pool and other options. 4. Start the pppoe server using the pppoe server command. Important considerations asterisk. Asterisk pppoe requires a network interface to be dedicated to pppoe connections. Asterisk security is crucial when configuring pppoe. Use strong passwords and consider enabling encryption. Asterisk properly configure the IP address pool to avoid address conflicts. 6. Hotspot creation, hotspot, DNS mask. Creating a Wi-Fi hotspot involves setting up a wireless access point and providing dhcp and DNS services to clients. Optionally, a captive portal can be added to require users to authenticate or agree to terms of service before accessing the Internet. Asterisk 6.1 Setting up a wireless access point with hotspot. Hotspot, host access point daemon, is a software access point that allows you to turn a wireless network interface into a Wi-Fi hotspot. 1. Install hotspot asterisk. 2. Configure hotspot, hotspot.conf. The hotspot.conf file contains the configuration for the access point, including the SSID, network name, security settings, and channel. Explanation asterisk. Asterisk interface, the wireless network interface, example OLAN 0. Asterisk driver, the driver to use, usually NL80211. Asterisk SSID, the network name, SSID, of the hotspot. Asterisk HW_mode, the hardware mode, example G, N. G is compatible with older devices. N and AC offer higher speeds but require compatible devices. Asterisk channel, the Wi-Fi channel to use. Choose a channel that is not heavily used in your area. Asterisk WPA, WPA_key_management, RSN_pairwise, WPA_passphrase, security settings for WPA2 encryption. Use a strong password. Asterisk 6.2 DHCP and DNS server with DNS mask. DNS mask provides DHCP and DNS services to clients connected to the hotspot. 1. Install DNS mask asterisk. 2. Configure DNS mask, dnsmask.conf. Explanation asterisk. Asterisk interface, the wireless network interface, example OLAN 0. Asterisk DHCP range, the range of IP addresses to assign to clients. Asterisk DHCP option equals 3, the default gateway IP address. Asterisk DHCP option equals 6, the DNS server IP addresses. Asterisk address equals //192.168.4.1, used for captive portals, optional. Redirects all DNS requests to the captive portal's IP address. Asterisk 6.3 Captive portal, optional. A captive portal requires users to authenticate or agree to terms of service before accessing the Internet. There are many ways to implement a captive portal. A simple method involves using iptables to redirect all HTTP traffic to a local web server. 1. Install a web server, example Apache or Nginx. 2. Create a captive portal web page asterisk. Create an HTML page that displays a login form or terms of service agreement. Place the page in the web server's document root, example /var/www/html. 3. Configure iptables for redirection asterisk. Explanation asterisk. Asterisk echo 1/proc/sys/net/ipv4/IP_forward, enables IP forwarding. Asterisk iptables tnata prerouting, redirect.